In this video, we'll take a look at graphs of the other trigonometric functions. In the previous section, we looked at sine and cosine, and in this function, we'll start with a graph of y is equal to the tangent of x. So remember that y is equal to the tangent also means that the tangent is the sine divided by the cosine. So that means wherever the cosine is 0, the tangent isn't going to be defined there. So if you take a look at values and plot some points to graph the tangent, if we take a look at the values from negative pi over 2 to pi over 2, at negative pi over 2, the tangent does not exist because the cosine is 0. And when the denominator is 0, it means we have a vertical asymptote at that place. So if I graph these points as we're looking at them, make this a little smaller. At negative pi over 2, there's a vertical asymptote. Then at negative pi over 3, which is about negative 60 degrees, then the tangent is negative 1.73, about there. At negative pi over 4, it's negative 1. At negative pi over 6, or about 30 degrees, it's negative 0.58. At 0, the tangent is 0. And then the symmetry at pi over 6, it's square root of 3 over 3, which is about 0.58. And then 1 and 1.78. And when we get to pi over 2, we have does not exist again. So that means there's another vertical asymptote at pi over 2. So if we connect these points, one period of the tangent looks like that. So the tangent is different than sine or cosine. Characteristics, the domain is all real numbers except for multiples of pi over 2. So we've got vertical asymptotes at negative pi over 2, pi over 2, and then the next one would be add pi to pi over 2. We get 3 pi over 2. So a way to express the asymptotes is at pi over 2 plus or minus any multiple of pi. So pi times k, where k is an integer. So that means starting at pi over 2, every pi is another vertical asymptote. You could go forward or you could subtract. So the domain is all real numbers except all real except pi over 2 plus or minus pi times k. The range, if you take a look at the y values, in this case is all real numbers, negative infinity to infinity. So the domain and range are different. We have vertical asymptotes, which we didn't have with sine and cosine. And then also notice that the period of the tangent function is equal to pi, and it was 2 pi with sine and cosine. So if we wanted to keep going, the key points, we had key points with sine and cosine. The key points with tangent, there are 3 of them. The negative pi, negative 1, 0, 0, and 1 pi, or 1, 1. Those are the points that when we do the transformations, we usually try to do the transformations on those 3 points so that we can sketch in our graph as well as the vertical asymptotes. So the key points are negative pi over 4, negative 1, 0, 0, and pi over 4, 1. And again, key points are the points that are that allow us to graph. So let's take a look. So how do we do a transformation? If we're given the function y is equal to a times the tangent of bx minus c plus d, how do we sketch the graph of one period? So if the function isn't already expressed in that format, express the function in the format. Then we identify the stretching or compressing factor, which is the absolute value of a. We call that the amplitude in sine and cosine. Tangent does not have amplitude, it's a stretch factor. Identify b and determine the period. Notice this time we're taking pi divided by b because pi is the period of the tangent function. Identify c and determine the phase shift. That's the same, c over b. Draw the graph of a times tangent bx. So we sketch that graph first, and then we shift it to the right or to the left, c over b, and then up or down by d. And then we also sketch in the vertical asymptotes. So notice if we're moving a graph to the right or to the left, the vertical asymptotes move to the right and to the left. So if we want to graph one period of the tangent function, y equals 2 times the tangent, 2x plus pi over 2, we identify all the parts and pieces. So a is equal to 2, b is equal to 2, and c is equal to pi over 2. So to identify the stretching, absolute value of a is equal to 2. So that tells me my key points at 1, negative pi over 4 and pi over 4 are going to be at 2 instead of 1. Identify b and find the period. B is 2, so the period is pi divided by b, which is 2. Determine the phase shift. The phase shift we're adding, so it's going to be to the left. C divided by b, pi over 2 divided by 2. Pi over 2 divided by 2 is the same as pi over 2 times 1/2. So we're shifting to the left pi over 4. So let's go ahead and sketch just before we move the entire graph to the left pi over 4. Let's graph a sketch of the transformed version. So the period is going to be pi over 2 instead of pi. So my graph of the tangent function is going to happen in the entire pi over 2. So that means my vertical asymptotes are starting at negative pi over 4 and pi over 4. And the distance in between those two is pi over 2. Now I want to sketch my key points. Okay, 0, 0 is a key point. If the stretch factor is 2, then that key point halfway between 0 and the first asymptote isn't land at 1, it lands at 2. And halfway in between lands at negative 2. Halfway in between would be at pi over 8, 1, or 2, negative pi over 8, negative 2, and then sketch. So that isn't our final graph yet, because we're taking our graph, that's the graph in blue, is y equals 2 times the tangent 2x. Now we're going to take our graph and move it to the left pi over 4. So if we move the vertical asymptotes to the left pi over 4, and then move each of our points over pi over 4, then the graph in pink is our final graph. And we sketch in the vertical asymptotes. And at one period, the vertical asymptotes are at x equals negative pi over 2 and at x equals 0. All right, so those are the three main trig functions, sine and cosine from the last section, tangent from this section. And then we also have, remember, there are 6 trigonometric functions. So we'll take a look at the graphs of the reciprocal functions. So the graph of the cotangent is equal to 1 divided by tangent. So that means wherever tangent is 0 now, cotangent is 0. So the graph of cotangent is listed below. So notice what's changed. The vertical asymptotes are still every pi, but they start at 0. Okay, so the domain is all real numbers except x equals 0 plus pi times k. So every multiple of pi is undefined. That's where a vertical asymptote is. The range is all real numbers. And the period is pi. So when you're graphing, these are the items that you take a look at when you're graphing by hand. Okay? You can also use a calculator. So I'd recommend you can use Desmos to help you graph. Okay, let's take a look at cosecant. Cosecant is 1 over the sine of x. So we have the sine of x graphed in the orange. And if cosecant is 1 divided by the sine, then notice wherever the sine is 0, there's a vertical asymptote. And then whenever we have, since it's the reciprocal function, at 1, pi over 2, 1, the reciprocal is still 1, so they share a point. They share the max-mins. So that's the general sketch. The domain is all real numbers except multiples of pi. The range is, let's see, so the domain is all real except, and I should just put pi times k, where k is an integer. The range is not all real numbers now. It's everything except it's not -1 to 1. So the range, the y values are greater than or equal to 1, along with less than or equal to 1, -1. So that would be from 1 to infinity and -infinity to -1. And then we have vertical asymptotes. The period is still 2 pi. And the vertical asymptotes are all the places where the domain is undefined. Okay, then the secant is equal to 1 over the cosine. So notice it looks very similar to the cosecant. And the domain, range, period are all the same, except the domain this time is undefined at pi over 2 plus every pi. All right, so when you graph these, I just want to show an example. You can use Desmos. Just make sure that when you click here that you're in radians, because your graphs will be in radians. You can adjust your window for the x and y axis. Notice I've got -6.528 to 5.28. So what you can do if you want the y-axis to be labeled in terms of trigonometric functions, you can write 2 or -2 pi for pi to 2 pi, 2 pi. And then if you want the labels on the x-axis to be in terms of radians, put step in terms of radians. Pi divided by 2. Then it should count, oh, I did it on the y-axis, sorry about that. On the x-axis is the one you want -2 pi to +2 pi. And then step pi over 2. There we go. The y-axis can be just negative whole numbers, -5 to 5. You don't have to put it in terms of radians. Okay? So that's how you, and step 1. So that's how you can adjust the x-axis if you want specific, if you want it in terms of radians, and then put the step in terms of radians. Okay, so that's how you use the graphing calculator.